All right. In the previous video, we look at question 5. In this video, we'll be looking at solutions to question 6. Let's get into it. All right. Question 6. The graph of f of x equals s squared minus 2x minus 3 and g of x equals mx plus c are drawn below. D and E are the x-intercept and P is the y-intercept of f. The turning point of f is T with a coordinate of 1 and -4. The graph of f and g intersect at point P and E. The first question is, write down the range of f. So what is range? What do you understand by range? Range represents all the possible values of y. Range represents all possible values of y. And from the question, we were told that T, which is the turning point of f, has the coordinate of 1 and -4. It means the x coordinate here would be 1 and the y coordinate will be -4. Since range is all possible values of y, it means that y will be greater than or equal to -4. You can see the lowest point here corresponds to a value of y equals -4. And this is the lowest point. Yeah, that is the lowest point on the graph. And from there, the value of y increases, right? So that means all possible values of y will be greater than or equal to -4. Question 6.2. Question 6.2. Calculate the coordinate of D and E. All right. So if we look at D and E, we will see that those are the two roots of the quadratic function f of x. All we have to do is to find the x-intercept by setting y to 0. So if we set this f of s to 0 and we solve for the two values of x here, those two values of x will be the x-intercept at point D and point E. So let's look at that. All right, so we set f of x to 0. I always like to factorize, but nobody forces you to factorize in your matric. So let's bring out our calculator and let's do this. So remember the quadratic formula, minus b will be minus 2. That will be plus 2, then plus the square root of -2 squared, -2 squared, minus 4 into a, which is 1, then multiplied by c, which is -3. Then we punch the down arrow, then 2a, that will be 2 times 1. That will give us 2. So that means that one of the root of x will be 3. Let's check the second root of x. So the first root of x, or the first value of x, is 3. Now let's check the value of x when we use this negative sign. So the value of x with the negative sign will be -1. So it means here that the x coordinate here will be -1 and the x coordinate at E will be 3. And you see they say we should calculate the coordinates. So the coordinate of y also comes into play here. So the coordinate of y here is 0, right? As we can see, y is just here. The coordinate will be 0. And the coordinate of y here will also be 0. The x coordinate will be 3 here. and the x coordinate will be -1 there. All right, for those of you that want to exercise yourself, you want to calculate it manually. So that is what I've done here. You can rewrite this equation as this, split it in two, then you factorize. So you have that. So it means that you have this, then you can drill down and solve for the values of x. So that means that x will be equal to 3 or -1, which is exactly what we got on the calculator. So coordinates of D, we have this, then E, we have these coordinates. That is question 6.2. Now question 6.3, determine the equation of G. To determine the equation of G, we can work with this point E, and we know the coordinate at this point E, and you can see that this point E also lies on G, this straight line, right? We have point G on that straight line, and the coordinate here is 3, 0. We can also see that P lies on this line G. So you can see P lies on F. That is what we see here. That is what we see here. P lies on F. So if we substitute x equal to 0 into function f of x, we will get a y value of -3. So that is what we have here. Then if we look at it, so P will have that coordinate. So P also lies on G of x. We've discussed that. Now, so we can see that the coordinate at E is 3, 0, and it also lies on G. So we can calculate the line, we can calculate the gradient of this line PE. So the gradient there will be 0 minus -3 divided by 3 minus 0, which shows that the gradient of this line is +1. And you can see it makes sense because it's a positive line, so it will have a positive gradient. So the y-intercept of G is at P, right, with a coordinate of 0 and -3. So it means that using the equation of a straight line, you know that this G is a straight line, y equals mx plus c. Since the gradient, which is m, is 1, so it means that m here will be 1, and you write the x here, and since your y-intercept here is -3, you just put that -3 there, and that gives you the equation of G. The next question is, write down the values of x for which f of x minus g is greater than 0. So we determine that from the graph. You can also determine it mathematically, but we determine it from the graph. So if f of x minus g of x is greater than 0, what you can do is make f of x the subject there. If you transfer -g of x to the other side, it becomes +g of x. So they are looking for the values of x for which g of x, the curve, will be greater than g of x, the straight line. If you look at it very well, we have this point. At this point, you would see that the curve will be greater for every value of x beyond this point of intersection, beyond this y-intercept. Every value of x will result in a value of y for f of x greater than that of g, right? So this point onward, that is x less than 0, would satisfy this condition. Also, if you look at this point E, you will see that beyond this point E, every value of x will result in the graph of f having a higher y value compared to the graph of g. So this point, x greater, any value of x greater than the x coordinate at this point, which is 3, any values of x greater than 3 would also satisfy this condition. Like I said, you can solve that mathematically, but you don't really need that. You don't really need that in this case. For question 6.5, they want us to determine the maximum vertical distance between h and g if h is negative f of x for the values of x between -2 and 3. For this question, we will have to solve some math, right? So let's look at how that would pan out. So if h of x equals negative f of x, then we can find h of x this way. So we just multiply f of x by negative and we expand that bracket. So it means that h of x will be equal to negative x squared plus 2x plus 3. Now, what we have to do is we need to find the difference between h of x, which is what we get here, and g of x, which we have calculated previously. So if you look at question 6.3, we calculated g of x, and that is x minus 3. So we have to look for the difference now. So, yeah. So that difference will be h of x, which is this, minus g of x, which is what we have here. We simplify that. And we have this. We can further drill down. So we have this. This is the difference. So the question is determine the maximum vertical distance between h and g. So whenever you hear the word maximum or minimum, then optimization should come to your mind. So they want us to differentiate at this point. Now, so let's differentiate this difference. So if we differentiate that difference, it gives us a value of, if you differentiate negative x squared, that will give you 2x. Then if you differentiate x, that gives you a value of 1, right? So what we can do now is to set that differential to 0 and find the value of x. So if you set this to 0, it means that x will be equal to half. You can then substitute this x equals half into this, and that will give you the maximum difference between h of x and g of x. So you substitute x equals half into the equation of the difference, into this equation here, right? If you simplify that, you will see that the maximum difference between h of x and g of x will be 6¼ units. Let's solve question 6.6. Given that k of x equals g of x minus n, determine n if k is the tangent to f. Determine n if k is the tangent to f. One thing we should note here is that a tangent is a straight line that touches a curve externally at a single point. A tangent is a straight line that touches a curve externally at a single point. So let's bring up the diagram. So you will use this diagram. This diagram will help you to solve that question 6.6. Right? So we will draw a tangent to that curve of f. And like I told you, a tangent is a line that touches a curve externally at a single point. So for this diagram and for the purpose of explanation, this is the point where this straight line touches this curve of f. And this line qualifies as a tangent because it only touches the curve externally only once, right? So once we understand that, then question 6.6 becomes easy. It becomes easier for us to solve that question. So k of x equals g of x minus n, and k of x equals, so g of x itself is x minus 3 from our previous calculation, then minus n, right? So now k of x is a tangent to f of x. So what really happens there is that if this k of x is a tangent to f, like I said previously, it means that it only touches the curve of f of x at only one point. So what we can do now is to set k of x to f of x, right? And we solve for x. Now, since a tangent meets a curve at only one point, we want to solve this equation such that we would have a single root. We want to have a single root here since the tangent only meets the curve only once. So what we can do here, in order to have a single distinct root, we set the determinant to 0. So if you set the determinant to 0, it means you will have a single root. So that is it. So we set the determinant to 0 in order to get a single root. So you should know that from the discussion on nature of root. So let's see how that works out. So here we set k of x to f of x. K of x is here, and f of x we were given. So we simplify that. So what can happen is that you can bring the content on the right-hand side. You can bring the content on the left-hand side to the right-hand side, and you set everything to 0. So tangent kx only touches f of x externally once. You have seen that. Remember, the discriminant is given as b squared minus 4ac. So we set that to 0. In this equation here, our b is -3, our a is 1, and c is n. We can make appropriate substitution. And if you substitute appropriately, you have this 3 squared minus 4 into 1 times n equal to 0. 3 squared is 9. Then if you expand this bracket, you get -4n. Here, we can make n the subject. So if you calculate properly, you will see that n would be equal to 9/4, which is what they ask us to solve in question 6.6. So determine N if K is a tangent to F. So through this calculation, you are able to determine the value of N. All right, thank you so much. If you have been with us to this moment, it means that you are committed to excellence in your mathematics, and I wish you the very best. You see, whatever you believe, then you can achieve. So you just have to believe that you can do it, and before you know it, you begin to practice and you begin to enjoy it. Thank you so much. In the next video, we will be looking at solutions to question 7. Question 7 has to do with financial math. All right, see you soon.